We are now going to look at how to perform operations when numbers are in scientific notation. We're going to specifically look at multiplication and division. And you could go ahead and take the numbers and write them in standard form, complete the operations, and then put them back into scientific notation, but that can be really inefficient. So we're just going to go through the process, and you'll find that a lot of times it's much simpler just to keep them the way they are. So in example number 1, we have 6 times 10 to the 3rd times 2 times 10 to the 5th. So for this one, if you think about what everything is, this is just multiplication, this is multiplication, and this is multiplication. So by the commutative property, I can actually just change the order. And you don't need to write this every time, but it's good just to, in the beginning, kind of get a sense of what's happening. So in the first two things, I have two factors. 6 times 2 is 12 times. And then I have my base 10s. So I have 10 to the power of 3 plus 5 is 8. So remember, whenever you're multiplying the same base, you add the exponents. And in this case, we multiplied those leading factors. You're not finished here because remember scientific notation, that first factor has to be between 1 and 10, less than 10. So that means I have to go from 12 to, I need to move the decimal behind that first non-zero digit. So I really need to make it 1.2. So technically what I've done is I've divided by 10. I've made it smaller by a factor of 10. Since I made it smaller by 1/10, I just need to give that 1/10 back to my base 10. So it would be 10 to the 9th. Example number 2, very similar. This is division, however. I have multiplication on top, multiplication on bottom. So when you have multiplication on top and bottom, no other operations like addition, subtraction, you can actually simplify. So we're kind of going to break it up. We're going to simplify this first. 18 divided by 4. I want to get that into decimal form. Sometimes these do get tough, the division. You actually do need to come over and do the long division, 18 divided by 4, and go from there. But I know that 4 goes into 18 4 full times. And then that's only 16, so there's 2 left over. So 2 out of 4 is a half. But again, if you needed to come practice some long division, you absolutely can. 4 goes into 25 full times. And there's my decimal pop straight up. And then remember, when you're dividing and you have the same base on top and bottom, what operation do you use? Hopefully you remember it's subtraction. So it's 10 times 10 to the 6 minus 4 is 2. And if that ended up being a negative, that's perfectly fine. For instance, if it had been 10 to the 4th over 10 to the 6th, and then when you subtract, you get 10 to the negative 2, that's fine. The only thing you want to do is make sure that this number is between 1 and less than 10, and it is. An example number 1, we're going to actually work through all of these. You're going to do a majority of them on your own once we get through a few more examples, but I will be stopping you, so it's good now to get a piece of paper and work through them with me. So 7 times 9 are my leading factors, so I'm going to go ahead and multiply those and get 63 times, when I'm multiplying the same base, 10 to the 8th, 10 to the 6th, I add my exponents. 8 plus 6 is 14. But I'm not done because that's not proper form, so I have to scoop a decimal in 1. So since I made it smaller by a scale factor, or by dividing by 10 once, I have to make this bigger by 1. So times 10 to the 15. Now just keep in mind this and the final answer, those are equivalent values. One's just in proper form, one is not. Number 2, so think through this one carefully because you've got 3 times 10 to the 4th over 8 times 10 to the 1. So I'm going to go ahead and put a 1 there just because I know no exponent means it's an exponent of 1. 3 divided by 8. So think through that logically. 3 divided by 8 is a fraction. That fraction is less than 1. So I know the value of 1/8 is 125 thousandths, but maybe you didn't know that. So again, long division, and I'm trying not to give you anything too crazy, but it is important you refresh your memory on how to do this. 8 doesn't go into 3. 8 goes into 33 full times, so that's 24. 8 goes into 67 full times with a remainder of 4. Last drop with a 0. 8 goes into 45 full times. So at this point, when I divide those leading coefficients, I'm at 375 thousandths times 10 to the, subtract your exponents. 4 minus 1 is 3. Hopefully you're already seeing that, that is the correct answer. It's just not proper scientific notation form. So I need to move the decimal over, this time to the right. So I am not going to lie. I always tend to get confused. Left, right, what do I do with my exponents? So I just think bigger, smaller. I've made my smaller number bigger. That means I've multiplied it by 10. I've given it an extra factor of 10 to move it to make it bigger. So if I do it once to make it bigger, I got to take that 10 away to keep it equivalent. So now it's 10 squared. For number 3, division, 4 over 5. That is less than 1. So I know my decimal is going to be less than a whole number. You can come over and do the division. This one's pretty quick. It doesn't go into 4, but it goes into 48 times, and I'm done. Don't forget to pop that decimal straight up. So I have 0.8 times 10 to the, when you have exponents on top and bottom, same base, subtract your exponents, I would get 2. So unfortunately, it's not proper form yet. I am in 0.8, so I have to scoot the decimal over 1. I have made it between 1 and 10, but I made it bigger than it was, so I have to make this smaller. So since I only scooped it once, I take away 1 times 10 to the 1. And really, you can just write times 10. For number 4, multiplication. I can multiply in any order I want. So I'm going to start with those leading coefficients. 2 times 3 is 6 times 10 to the, I'm going to add my exponents. 3 plus 4 is 7. This number is between 1 and less than 10, so I'm good to go. I am done. Simple as that. If you have not gotten a piece of paper and been practicing with me, now is a good time because I'm going to stop you and ask you for your answers. So we're going to start with number 5. Take a moment and solve number 5. Hopefully you got 2.7 times 10 to the 14th. Multiply 3 times 9, add your exponents. 27 was too large because it's greater than 10. So I scooted the decimal to the left. I made it smaller by dividing by 10, so I got to give that 10 back, and that's where the 14 came from. Take a moment and try number 6. Hopefully you got 2.5 times 10 squared. I used my knowledge of fractions to convert it to a decimal versus do long division. 4 over 16 is the same thing as 1/4. 1/4 as a decimal is 0.25, which I have shown you right here. 0.25 is not proper scientific notation form. It's got to be 1 or more. So I scooted the decimal to the right. I made it larger by a factor of 10. I've multiplied by 10, so I got to take one of the 10s away. So I made it 10 squared. Take a moment and complete number 7, and then go ahead and complete number 8. For number 7, I again didn't use long division. I know that 9/10 is a decimal, is 0.9, 9/10. That number is too small, so I had to make my number 0.9 larger by multiplying by 10. I have to take that 10 away. So I have 9 times 10 to the power of 1. If you put the 1 there, that's perfectly fine. 11 times 7, and this is number 8, is 77 times 10 to the 6th, because I added my exponents. 77 too large to be in proper form. So I took and divided by 10 to make it smaller. Since I divided by 10, I've got to give that 10 back to keep these equivalent. So I have 7.7 times 10 to the 7th. Hopefully that makes some sense. And again, I did keep these somewhat simple. You are now going to move into Khan Academy, where you'll be working with some that are a little bit harder to divide, and then you'll also have some exponents that are negative, which makes it a slight bit more difficult, but it shouldn't be out of reach.